So in the last video, you learned how to multiply rational functions. So now we're going to look at how to divide. And dividing rational functions is basically the same thing as multiplying, but we've got one extra step at the very beginning we need to take into account. So let's just look at a basic fraction division problem here to start. If you remember from middle school or whenever you learned how to divide fractions, there was a little thing that you may have heard that said keep, change, and flip. And what that means is I'm going to keep the first fraction as it is. So 3 over 10 is going to stay 3 over 10. Change means that I'm going to change division sign into multiplication. And flip means I'm going to take the reciprocal of the second fraction. So I'm going to flip it upside down. So that's now going to become 5 over 2. And now we have a multiplication problem with two fractions, and we know how to simplify that. So 3 times 5 is 15. 10 times 2 is 20. And then this fraction, I can reduce it. I can divide 5 into both of these numbers. So that'll become 3 over 4. So in order to divide fractions, we keep the first one the same. We change the sign to multiplication, and we flip the second fraction. So let's look at what a rational functions problem would look like. So here, we've got this rational function on the left divided by this rational function on the right. So the first thing you want to do is rewrite it so that it's a multiplication problem. So I'm going to keep the first fraction the same, 6x plus 30 over x minus 7. I'm going to change my division sign to multiplication, and I'm going to flip this second fraction. So now the 2x minus 14 is the numerator, and the 5x plus 25 is the denominator. From here, I'm going to follow the same procedure, the same steps that we followed when we multiplied rational functions. So I'm going to start with the left-hand fraction, and I'm going to factor it. So 6x plus 30, I can take out a greatest common factor of 6 from both of those terms. So I'm left with 6 times x plus 5. X minus 7, that can't be factored, so that stays the same. On the right, 2x minus 14, I can take a 2 out from both of those terms, and that leaves me with 2 times x minus 7. Over 5x plus 25, I can take a 5 out. So that's going to give me 5 times x plus 5. And from here, you can start to see the things that are going to cancel each other out. So in the numerator, I have x plus 5 over x plus 5. The numerator, I've got x minus 7, and the same thing in the denominator. So what do we have left here? In the numerator, I have 6 times 2, and in the denominator, I just have this 5. So let's simplify. 6 times 2 is 12 over 5. That doesn't reduce. That's your final answer. So go ahead and pause the video, try the remaining examples, and then start it back up to check your answers. All right, second example. So first thing you want to do, rewrite the problem, leaving the first fraction the same. So 3x over 2x minus 8. Change the sign from division to multiplication, and then flip the second fraction. So now it's x squared minus x minus 12 over x squared minus 6x. And go ahead and factor. So on the left-hand side, the 3x over 2x minus 8. 3x can't be factored. 2x minus 8, I can take a 2 out. So that becomes 2 times x minus 4. Second fraction, I can factor x to the second minus x minus 12, and that factors as x minus 4 times x plus 3. In the denominator, x to the second minus 6x, I can take an x from both of those, and I'm left with x minus 6. So I'm going to go ahead and start canceling out. Not a whole lot to cancel out here, but I do have x minus 4 and x minus 4. And this x with the 3, since all of these things are being multiplied, I can cancel out this x that's beside the 3, and the x down here that's beside the x minus 6. Those will cancel each other out. I don't see anything else that cancels, so let's go ahead and write our final answer. In the numerator, I have 3 times x plus 3, and then the denominator, I've got 2 and x minus 6. And I can distribute these in, get rid of parentheses, so 3x plus 9 over 2x minus 12. Next example. So keep the first fraction the same. So x squared plus 18x plus 32 over x minus 5. This division sign becomes multiplication. There is a typo on this screen. This 30 should be positive. So if you haven't changed that yet, make sure you change that to a plus 30. All right, so we're going to flip this second fraction. So x to the second minus 11x plus 30 divided by 2x plus 4. All right, let's go ahead and factor. So x squared plus 18x plus 16, I'm pretty sure that factors in x plus 2 times x plus 16, all over x minus 5 does not factor, times second fraction, x squared minus 11x plus 30, that's x minus 5 times x minus 6, 2x plus 4, take out a 2. So you have 2 times x plus 2 left. So let's go ahead and cancel out anything that's the same. Numerator, x plus 2, x plus 2. Numerator, x minus 5 in the denominator. So in the numerator, I have x plus 16 times x minus 6 all over 2.